Okay, so before we actually do any work on tree diagrams, sorry, my PowerPoint seems to have closed, just give it a second to load up. Before we do any work on tree diagrams, we need to actually understand a couple of rules. So let me just get there. Okay. So here's a couple of rules we need to understand. Okay. Two important rules. You might want to make notes of these and write them down. So just using the language, what's this? The probability of A and B is equal to the probability of A times the probability of B. The probability of A or B is equal to the probability of A plus the probability of B. So if I'm using that word and, I'm looking at multiplying. And if I'm looking at the word or, I'm looking at adding. Now, I wanted to tell you actually that these are actually wrong. These rules are only correct in certain circumstances. It's not always true what is written here, but I don't want to overcomplicate the issue for you. When you get to IB, you'll need to unlearn these rules because they're not always true. If anybody wants me to explain why these rules are not true all the time, then let me know. But I want you to understand that when you're using the word and, you're looking at multiplying. When you're using the word or, you're looking at adding. Okay? So remember these two rules, but also remember they're not really true, actually. They're only true under certain circumstances. Okay? But anyway, bear that in mind, because now we've got a question where we are going to use a tree diagram to solve it. Okay, so let's just read it. It says, a marble is selected at random from each of the bags alongside. Draw a tree diagram to display the possible outcomes. So that's going to be so the tree diagram is my sample space diagram. Find the probability of obtaining a green marble and a yellow marble. Now, what we've got here is we've got two events. We've got taking a ball from bag A, and then we've got taking a ball from bag B. So what I'm going to do, this is how a tree diagram works, okay? I'm going to say, let's look at bag A. That's my first event. Okay? And by the way, when you make tree diagrams, you need to make them big and beautiful and clear, okay? Now, from bag A, I can either get a green ball or I can get a yellow ball. And what I'm going to do is I'm going to write down the associated probability. So the probability of getting a green ball is 3/5. And I write that on the branch, okay? And the probability of getting a yellow ball is 2/5. Branches that are connected should add up to 1 because one of them has to happen. Okay? Then my next event says, let's look at what happens when I go for bag B. I pick a ball from bag B. Well, actually now I've got 3 possibilities. So what I need to do is branch out into 3 possibilities. I can get a green, I can get a yellow, or I can get an orange if I got green first. But if I got yellow first, I can also get a green, I can get a yellow, or I can get an orange. Okay? And now what I need to do is write down the probabilities of each of these. So what's the probability of getting a green from bag B? There's 1, 2, 3, 4, 5, 6, 7 balls in total, 4 of which are green, so it's 4 out of 7. I can get a green or I can get a yellow out of bag B, which is 1 out of 7. And I can get an orange, which would be 2 out of 7. Okay, but also what I could have done is I could have got yellow first and then a green. Well, notice that what happens in bag A, my selection of bag A, has no bearing on what happens with bag B. So these probabilities are the same. Talk about that more in a minute. 1/7 and 2/7. Okay, so here is my tree diagram. And what that's going to help me to do is list my outcomes. So here is going to be my sample space. I'm going to use a different colour. I can get green and green, green and yellow, green and orange, yellow and green, yellow and yellow, yellow and orange. And then what I can do is I can now work out the probabilities of each of those outcomes. So remember the rules. And means you multiply. So I'm saying what's the probability of green and a green? It's 3/5 times 4/7, which is 12/35. Green and yellow, 3/5 times 1/7, which is 3/35. Green and orange would be 3/5 times 2/7 equals 6/35. Yellow and green, 2/5 times 4/7 equals 8/35. Yellow and yellow, 2/5 times 1/7 equals 2/35. And lastly, yellow and orange, 2/5 times 2/7 equals 4/35. My suggestion is you don't simplify your answers because it actually complicates the issue with probability. Okay, so there we go. We've got each of the possible outcomes, but notice each outcome is not, they don't have equal likelihoods. So the probability of getting 2 greens is not 1 out of 6. The probability of getting 2 greens is 12 out of 35. Okay? The question says, find the probability of obtaining a green marble and a yellow marble. So it doesn't really care what order. It could be yellow-green or it could be green-yellow. So which of these outcomes matches what I want? Okay, well actually this one does. And also this one does. So listen to the language I'm using. It could be this one or it could be this one. So the probability of getting, the probability of a yellow and a green in any order is this one, 3/35, or this one, or A or B. Okay? And so the answer is 11/35. So hopefully you now understand why you don't want to simplify things, because it just becomes easier to add the fractions. Okay, because you can keep the common denominator. All right? So I hope that makes sense. So this is a tree diagram. It basically is used to list out all of the different outcomes there possibly could be, but then acknowledge that not like all of the outcomes have different probabilities, which we find out because we multiply along the branches. Green and green is 3/5 times 4/7. Okay, and then when you know all the outcomes and the probabilities, you can use the addition rule, the OR situation, and add them. So we multiply across and we add down or up. Okay? Now the only way to really master this is to practice. So I'm going to stop the video there. In the next videos we're going to